Okay, superannuation, as you probably know, is an amount of money that's put aside in your pay each week, and it earns interest, and you're allowed to get it once you retire. We have questions in superannuation in mathematics that end up to be a series question. So this is our application of series. And I'll do a question and then I'll come back to the steps, because each time it is exactly the same. So we'll just have a look at this question. It says a man invests $750 at the beginning of each year in a superannuation scheme. If the investment is paid at a rate of 8% per annum, compounded annually, how much will he have at the end of 20 years? Well, you can't just say it's 750 times 1.08 to the power of 20 like we did in compound interest, because he puts the money in at the beginning of each year. So let's have a look what's happening at the beginning. Let's look at what happens at the beginning, at the first year. Year one. He's got $750 in the bank and he earns interest for 1 year. The second year, he puts another $750 in the bank, but he has the balance of the year before. He has last year's $750 times 1.08, and that whole lot earns interest. So he's got, this is the first year's, this is the second year's, and they earn interest. Now, what do you think is going to happen on the third year? We've got the third year's plus, and I'm going to expand this out, the second year's, which has only earned interest for 1 year. The first year's has earned interest for 2 years, and they all earn interest for the third year. So I've got the first year's, it's been sitting there for 1, 2, now it's its third year. The second year's has been sitting there for 1, 2 years, and this is the third year's money. Now, if I was to do the fourth year, you could probably guess the pattern. We're not so much interested in the fourth year, we're interested in the nth year or the 20th year. Let's go to the 20th year. We've got this pattern happening, and I'm just gonna expand this. 1.08 squared plus 750 times 1.08 cubed. Now let's note that the third year, the number of the first payment is the same. So in the 20th year, I'm going to have 750 20 times. I'm going to do it in green. That's the first payment. And I'm going to have, the second year is always one less than the third year, so it's 750 times 1.08 to the 19. And the third year's money has been in there for 18 years. Are you seeing a pattern? So the 20th year, which is at the end, that's what I'm after, is 750. And I'm going to have 1.08 plus 1.08 squared plus all the way up to 1.08 to the 20. Okay, so this comes down to 1.08. Right, this is a GP. So I'm going to say the amount is actually equal to 750 times some value. Let's call it V. Now what is that V? It's the sum of a GP, which is A 1 plus R on 1 minus R. What is A? 1.08. What does it go up by? Each time it goes up by 1.08. How many times? 20 times 1 minus 1.08. I'll put that in my calculator. Okay, I put the wrong formula in here. I just thought I remembered it, and obviously I didn't. So it's A R to the n minus 1 on R minus 1, and you get at the end 49.4. So how much do we have at the end? We have $750 times by this sum, 49.4. And you get $37,067.20. Now if we go back up to the steps, it says write out the first 3 years to establish a pattern. We did that. Factorise the investment to isolate the series. We've done that. Identify AR and calculate the sum. That will always be over here as something separate. Work out the final payment. I will do a whole heap on the board, so don't panic.